Okay, so we are doing 5.3. I am splitting it up, so this is the first section, properties of logarithms. This is going to involve quite a bit of memorization. I'm not a fan of memorization, and to tell you the truth, I'm really bad at memorization. I need to understand things. But this is one of those things, this is similar to the exponent laws. So remember way back when you first learned about exponent laws, you didn't know those, they were foreign, it was brand new. This is sort of the same type of thing happening. So even the names of them, you'll see, they're similar to exponent laws. So we kind of just have to go through, and I'll give you an example of each of them, and then we'll put it all together eventually. Okay, so the first one here, log b of 1 is always equal to 0. I'm just going to really quickly show you the reason for that, again, because I feel like understanding is the best way to grasp the concept. If I were to write this in exponential form, what would this look like? Malcolm? Thank you. B to the 0 equals 1. So do you see it doesn't matter what I plug in for b, anything to the power of 0 is always going to equal 1. So that's why number 1 is a rule. Good? Okay, so again, the more you practice these, you're going to start to pick up on them and it'll get a bit better. Number 2, log base b of b equals 1. Yes. Thanks, Ian. So b to the power of 1 is equal to b. If we think about that, that makes perfect sense. So there you get to see where that's coming from. So far, not so bad? It's making sense? Good. And then I think that these you're hopefully going to find they're not too bad as well, because they do kind of resemble what we did for exponent laws. So if we have log 7 plus log 8, we get log 56. I wanted to show you first with numbers so you could wrap your head around it. So if we want to write this as a rule, what does it look like as a rule? Log, it doesn't really matter, but maybe to keep it consistent, log base b of xy equals log b of x plus log b of y. I did it the opposite way. I'm trying to show you, like, take a look at this versus this. I'm trying to show you that, again, like everything, we can go forwards and backwards with this. So, that making sense? And do you see how it kind of resembles what we do with exponent laws? Good. So I'm not big on naming things and knowing what they're called, but so yeah, it is called the product rule, and I think you're naturally going to kind of know that because of exponent laws, but I more am interested in you knowing what to do in the questions. Next one is the quotient rule. Well, it's kind of exactly what it sounds like. You kind of know the quotient rule. Oh, you know what? I just like using the highlighter, so I'm going to do it. Isn't it just, it's so much nicer if it's colorful. So, if we have log base b of x over y, it's log base b of x minus log base b of y. I'm optimistic that you're seeing it this way, but do you see how it's similar to and resembles exponent laws? Good. So I think if you use that approach, linking it to something you already know, you'll find that it's a little easier to understand it. And then just to show you an example of what that would look like with actual values, log 80 minus log 16, and we end up with log 80 over 16. And the reason why I've written exact value form is you could punch this into your calculator to spit out an answer. Actually, take out your calculators. We don't really need to do this, but We might as well throw this in. I bet you anything I'm accidentally teaching you something that's later in the lesson, but that's okay. It feels natural to do this now. On your calculator, look for the log button because it's possible that you've never used it or even found it before. Right? Once you have found it, usually the way that it goes, it depends on the calculator, is like on mine, for example, I hit 5 first and then I hit log. On some others, you'd have to hit log and then 5 and then equals, and that'll give you an answer. What do you get? Okay, this is so unexpected. This is not what I was expecting. I was thinking we'd all get the same answer. Yeah, 0.6987. Good? Did we all get that? Okay, good. This was... Okay, good.
We were just talking about like the decimal.
You just added the extra 0, 0, 0.
Got it. Okay, good. So just making sure that you're familiar with it. And also, we kind of talked about this yesterday, but if nothing's written there, what's the base of that logarithm? 10. So when you punch it in on your calculator, it's base 10. If you're punching it in, if you're using the log button, you can only use it for base 10. Make sense? Look above the log button. What does it say? In yellow or orange or 10 to the x. Do you see the relationship between those two? Yeah, so it's the inverse, right? It's showing you the opposite at the top. And if we wanted to get to the thing at the top, obviously we'd hit second function or shift to get to it, but we don't need to worry about that right now. But I just thought I would at least introduce you to it. Good? Okay, so exact value form is just leaving it as log 5. That's actually better than changing it to a decimal because it's more accurate and more precise. As you saw when we punched it in, if it gives you a bunch of decimals, we would have to round it, which takes away some of the accuracy. And if we were to take this log 5 and do something else with it, like use it for something, then each time you round off a decimal, you're making it less and less accurate. Does that make sense? So whenever possible, we like to leave things in exact value form. So that's usually a fraction instead of a decimal. Depends on what it is, though. If we're talking like money, for example, you don't want to say, I have $5.25. Well, a quarter, oh, that was a horrible example for me to use. But you get the example? You get the idea? Sorry? Okay. Next one is power rule. Log base b of x to the power of k. Okay, this is a weird one, so I'm going to zoom in on this a little bit. If you have, like this we're used to seeing, and we saw quite a few of them yesterday. If you have all of this and it's to the power of something, we can take that exponent and just swing it to the front, so it ends up being k log b of x. I'd say that's the first one that is unique or doesn't quite resemble what you've seen with your exponent laws. Good? Okay, I haven't shown you this, but I want you to try this. Can you think your way through this? It says simplify using the power rule. Well, it doesn't look like what the power rule started with here, but can you use your log skills to try to make it look like that and then apply the power rule? I'm going to give you a minute. I can see the looks on your faces. You can do this. So you're sort of applying some of the stuff that we went through last day. Okay, so first of all, can you think of a way of rewriting this to make it look a little more like this thing here? Emmy? Yeah, log base 3, and this can be rewritten as 3 to the power of 3. Okay, this is confusing, but you know what we're going to do? Take away the confusion with some colors. Is that better? Okay, so to apply the power rule, what do I then need to do? Move the 3 out front, so we end up getting 3 log base 3 of 3. That's how this would look. Isaac?
Why does it work?
Oh boy. Why does anything work?
No, but it is actually interesting. How does that work?
You are a horrible class. You're doing this to me on a Friday morning when I'm trying to teach you the basics of how about I love that you're interested and you want to know that, but we just can't do this right now. Let's put it off to after going through this. Is that okay for now?
No,
Okay.
this is not okay.
Okay.
We're trying to learn math.
I know. Stop it. Okay. Change of base rule. I'm going to give you a minute just to look at that because I get that this is... I wish I could turn this around and show your facial expressions when I introduce something new because some of you look disgusted, stunned, surprised. Okay.
There's like suddenly an X there.
Oh boy, if you were asking, Isaac, if you were asking that about this last one, your mind's probably going crazy when you see this one.
How are we supposed to remember this if we don't know how it works? I get the first 2 or 3, but like these ones are just like, what? Are we gonna have a formula sheet on the test?
Are you going to have a formula sheet on the test?
No way.
Do you need a formula sheet on the test? I think you only think that you need it right now because it's the first time you're seeing it. I promise you, by the time you're done going through the workbook questions, you're naturally going to memorize these because you'll be doing the same thing over and over again. But how's this? I think this is fair. We haven't had a provincial exam in grade 12 for years, but this is what I use as my guide. When you did have the provincial exam, they did give the formula sheet, so I will share with you whatever was on there. So I'll have a look after we're done here and let you know what will be included. Good? I don't know if all the details of this were on there, but you won't need it, trust me. But if you feel like you do, I mean, whatever, it's not a big deal. I can give them to you. Okay, so let's take a look at this. I think the best way to demonstrate this is using this example because I get that looking at this, it's very confusing. So anytime, like you know how I just finished telling you that on your calculator, when you use the log button, it's base 10? So if you have something that isn't base 10, so if this b down here is a 5 or 7 or 3 or something, we are still able to change it so that it is base 10. So for example, I could change this to make this log, I don't need to write the 10, well I'm going to, just so you really get what's happening, over log base 10 of b. So this is a rule. We're allowed to separate something like this as long as we keep the same base at the top and the bottom. And I could substitute in any number that I want for that base. So it doesn't have to be 10, it could be 3, it could be 5. And depending on what else is happening in that equation, we may want to be picky with which number or value we're choosing. I think how it becomes most beneficial or helpful is when we do change it to base 10. So it actually would be log A over log B. And if I knew the numbers for A and B, I could just punch that into my calculator. And so it allows us to solve something that we otherwise wouldn't be able to solve. Good? Okay, so find log base 3 of 7. How would I write that? How do I apply the change of base rule? What would it end up looking like? Malcolm? Log 7 over log 3. Again, it's a big mind shift when you first look at it and you think like, what? Where did the x's come from? Blah, blah, blah. But it's actually not too bad once we see the application of it. That's not too bad. So just remember that the little 3 that was at the bottom anyways ends up being at the bottom of the fraction. Good? And then find it to 2 decimal places. Well, go ahead. You would want to do log, remember, you're not doing log and then 7 over 3. You want to do log 7 divided by log 3. There's different ways. For some calculators, you have to put brackets at the top before you divide by the bottom, blah, blah, blah. If you want to be super safe, you could just do log 7, get your value, and then do divided by log 3. But let's get what it's approximately equal to, and it says to 2 decimal places. Can somebody tell me what it is? So do try it just so you get a sense of how to do this. Thank you, Emmy. 1.77, we would round it down, so that looks good. Good? This squiggly equal to sign means approximately equal to, or if sometimes you'll see the equal to sign with the dot on top. I don't know if squiggly equal to sign is the proper term, but we're going to use it. Good? Okay. Use log rules to simplify and evaluate. I want you to take a few minutes to try this on your own, because here's your chance to see if you actually understood and retained those rules we just went through. If it says and evaluate, that means find the answer, right? So maybe what's reasonable? Let's say 2 decimal places is reasonable for each of them. Yeah. If it says evaluate, that implies that you have to find the answer. I mean, if you were to leave it in a exact value form, it's not going to be wrong. I just want you to practice taking it that extra step so that you also can start to wrap your head around like what number on a number line log 2 or log 5 is equal to. Good? Okay, so what is the first one? Do you see the pattern? We always start off with something like big and then we shrink it down, and that's our attempt at simplifying. Or that's our goal anyways, and that's why we're using all these math skills, is to shrink stuff down. So if I can get it to a single logarithm, that would be us simplifying. So what is it as a single logarithm? Thank you, log 50 over 25. So we're applying, what do we call that rule? The quotient rule. And that's the same thing as log, those are both in the brackets. It's not separate logs, so we can just simplify it, right? So, and then when you punch it into your calculator, what is log 2 approximately equal to? 0.30. Everybody okay with that? Yes.
In the test, we are not allowed to have calculators, so
So you would leave it as log 2.
Oh.
Yeah, I just want you to, again, get the concept and start to understand when you see something like log 2, like what number is that if we put it on a number line? So you're starting to see what it equates to. Good? Emmy? Oh, stay tuned. We'll have those. Yeah, good question. How about B? What does that end up being? When we put it together, we just multiply the 5 and the 12, right? So we get log 60, and what is that approximately equal to? Maybe 2 decimal places is reasonable? 1.78. Are we all good with that? Okay, you know how this works. We're starting off very basic, we're taking little baby steps, and then we're going to start adding to it. But we're all good so far? And you feel like that's helping you to get the skills? Good? How about C? Looks a little bit different. What is this the same thing as? Log 4 to the power of 3. And what is 4 to the power of 3? So basically, we just want to punch in log 64 into our calculator. Good? And what approximately is that equal to? 1.81. Log 64, so 64, you'd think it's a large number. You can see the impact that the log has. It ends up being 1.81 on the number line. Does that make sense? Okay, so that's the only reason I wanted us to use our calculators and to start to do this is so you can start to wrap your head around like what this actually is. Good? See, it's starting to get fun. Simplify and write as a single log. Go ahead. I'm going to give you a minute or two. You look like you're just casually hanging out, having a good time. Good.
I finished the question.
Good. I believe you. Are we good to go? So again, remember taking the step-by-step approach. If we just ignore the other part and focus on this, our goal is always to take what starts off being like a long equation and shrinking it down. So how can I shrink this down? What is this the same thing as? Log x squared. And then I do have minus log y. You don't have to split it up and write all the steps. I just want to make sure that it's clear in your notes. What's the last thing to simplify this? Like our goal is to try to get it to a single log if we can. So what is it as a single log? Yeah, log x squared over y. So we're just taking them and putting them together using the quotient rule in the last one. Good? Okay, then go ahead and do B on your own if you haven't already done so. Again, just adding in another layer. And so nothing really is more difficult necessarily. We just add on more steps. But if you take that step-by-step approach, I think you'll find that it's not difficult. It's just a little bit longer. There's more stuff to keep track of. Are we good to go? Not quite yet. Uh-oh. It's okay. I mean, that's so pleasant. I don't mind. Just keep it going. Okay. Let's just start like bit by bit. So this first one, what's that going to be?
Oh my god. It's my keys are in the back pocket and I have a tile.
What?
A tile? Yeah, it's like
What do you mean? What is that?
like if I press this twice,
Yeah.
my phone would send out like a really loud sound, like just sitting right now, so I can find my phone with my keys. And I can find my keys with my phone.
Okay, this is like a whole new world. I didn't even know that this existed.
Really? Yeah, I have tiles for like pretty much everything. Like my bag, my camera, my hobo, my bike, my
What?
whole thing. Yeah.
So you stick the tile on your bag, you
Yeah.
mean? And then so if you lose it or leave it behind somewhere,
Yeah.
your phone helps you to find it?
And my phone actually, I can check out what I'm bringing each day, and my phone will send out a really loud noise as soon as I leave the house without something that I have.
Okay, this is so funny to me.
I want that.
Right? It's pretty good. Yeah.
That's awesome, but also kind of like
It's
wow.
It's kind of like Big Brother, you know?
Yeah.
Sort of.
So you basically don't even need your brain anymore. Like you can
Yeah,
just
pretty
you can
much.
just let go and
Yeah.
wow. Okay. Well, thanks. Thanks for teaching me new things. Okay. So, do we see that this is going to be log x to the 1/2? And then keeping this going, if we go on to the next one, here we'd have minus log y cubed. And then if we go on to this one, we're going to have plus log z squared. Good? Okay, so then I feel like this sometimes throws people off a little bit. Because we have 3 different terms to keep track of, I don't know what you're going to find easier or harder to, I know. Let's do all of it at once. So if we want to shrink this down to make it a single logarithm, I'm going to do this. I'm going to put a big set of brackets there. And we know that we're going to have a fraction, right? Because of the fact that we have that minus sign there. So it's a quotient rule. But we also have a plus sign here. So we know that it's also product rule. So maybe an easy way to look at this or to apply it all at once is to decide what goes at the top of the fraction and what goes at the bottom. Does that make sense? So we have a single logarithm. We only have this thing, and this thing to keep track of. So what's going to go at the top? This goes at the top. Yeah, x to the 1/2. And what's a better way of us writing that? Root x. And what else goes at the top? Z squared. And there's a plus sign there, so we can multiply these two. Does that make sense to everybody? If not, please do ask me and I can clarify. And then at the bottom, we'd have the y cubed because that was being subtracted. Good point. Thank you, Everin. It only works because they all are the same base. They all have the same base, which is 10. If there's nothing written there, we assume that it's 10. Yes?
Another way to write this would be log z squared and then multiplied in brackets root x over root y cubed, right?
Yep. Yep, same thing. So this order doesn't matter, and in fact, the other way around might be better to put the root after. But yeah, same thing. Good? So far, so good? This is the stuff that makes people cry and have breakdowns. We're good? Isn't it good? Good. Okay, so how about this? Write each expression in terms of log A, log B, and or log C. So this is doing the opposite. Do you see if I compare to what we just did, we are now starting with a single logarithm, and it's asking you basically to separate them. Does that part make sense? So we're going backwards. We always do this. We're doing the opposite of what we just finished doing. And again, this is just, I think you can think your way through this because it's not necessarily a new skill, it's just going the opposite way. So I'm going to give you a minute to try A and B on your own, and then we'll go through the solution together. It's a 2 at the top. Oh, that's my comma. That? Yeah. I know. Actually, I'm impressed that none of you have complained about my printing so far.
Believe it or not, it gets much worse. Like,
Oh,
It gets much worse.
you know, like I have
Who are worse than this?
yeah.
I even try to write neater. I just can't do it. I give up. This is who I am. You have to accept it. Yeah. Okay, if we start to look at this first one, let's take the step-by-step approach again. First thing I want to do is separate the a to the z and the c. So I want to rewrite this as separate logarithms. How would I separate these two? And or how can I rewrite this? Log. Oh, this is a squared. Yeah, plus log c. It could be z. It doesn't matter. Same thing, I guess. Good? And then if it's asking us to write it in terms of just log a, we can take it a step further. What could we change this to? Good. 2 log a plus log c. So in a sense, I could say that this is like expanded form when we're looking at logarithms. When we're simplifying, we try to shrink it down to a single logarithm, and in expanded form, we're basically spreading this out to get separate logarithms. So far, so good? Okay, let's take a look at the next one. So again, let's take the step-by-step approach. If we want to separate the stuff that's in the brackets here, how can I rewrite this as separate logarithms? Which one am I going to start with? Log a squared. And then what? Minus log b. Everybody good with that? Because b's at the bottom. We know it's the quotient rule. And if c cubed is also at the bottom, what do I do with that? Pardon? Also subtract it. Yeah, so also subtract minus log c cubed. Good? So it could have happened this way or the other way. Am I going to mess you up by doing this? No, I don't think so. Don't do this. I just want to show you. If we had, or I could have done brackets and made it like this. Do you see that that's exactly the same thing? And the reason I say that is if you want to keep these two together and then deal with them at the same time. So you take your pick of what makes the most sense to you, but they're exactly the same thing. And then we just want to separate them even further. 2 log a minus log b minus 3 log c And I'm just writing them out for you because I feel like you're all okay at this point with that. Good? Yes.
Can we, so, in this case, should we not write that as 2 minus in the brackets 1b plus 3 1? No?
Sorry, say that again. Minus.
Like in brackets, so instead of the minus 1b minus 3 1c.
Do the brackets here and then
yeah,
plus?
Yeah.
Oh yeah, so I just finished saying either one is fine. They're both the same thing. But I would say when we're simplifying, getting rid of brackets is probably a better way to go. But it's not wrong. If you leave it with the brackets and have the plus in between, that's totally fine. It's the same thing. Good? Okay, find the exact value. A lot of stuff happening there, but just think your way through. You can look back at your log rules if you like. No. We're going to, let's go through it together maybe, if you're wondering. Exact value just means like don't change it to a decimal or don't, yeah, so you just leave it. Maybe I shouldn't have written that and it wouldn't have been confusing, but it's good to know what that is. Okay, so do you see that we could, oh, well, that's the wrong color. We can't have that. Log base 5 of 5. If this is root 4, what is that the same thing as? To the power of a quarter, 1/4. Good. And then we can move that forward using the, do you remember what that rule is called? The power rule. So this is a quarter log base 5 of 5, and you're going to love this rule because it makes your life so much easier. You have log base 5 of 5. What is that? That's just the number 1. Remember the, I don't know if I numbered them, but at the start we went through a few rules. It was the second one that I went through. The reason for that is because think of what this would all be as an exponent. 5 to the power of blank equals 5, and that's how we get this 1. Does that make sense? So anytime you have the same base at the bottom and the same number here, they just cancel out and leave you with a 1. So the answer after all that is just a quarter. Good? Questions? No questions? Okay, go ahead and do the next one. We're almost done. Yes.
The music, is it on a loop? Like were you on a loop?
No, it's off of a YouTube playlist, and I think it's like 3 hours long.
Oh, right.
And it amazes me that no ads or anything come up. It just works.
So those are placed by the person who made the video.
Pardon?
Those are placed by the person who made the video.
Oh, so I guess it just happens to be a video where there isn't.
If they want to be continuously monetized.
Oh, okay.
Yeah.
Thank you. That's good to know.
The thing is because it's organized by key. Like all the songs have the same key as follows. And then now it's just third down. That's why it seems like you never.
Is this how you feel about math? You lost me. Like you mean it's repeating the same?
No, basically it's like organizing light frames. The songs that sound the same are put next to
That was the best thing I've ever heard. Did you guys hear that? It's like organizing like terms.
Yeah, like the songs that sound like each other are put next to each other, essentially.
Oh,
Yeah.
thank you. That was brilliant, Everin. I get it.
He's going to university for music.
That makes perfect sense. You know that math and music are very closely linked? Oh, actually, when we get to trigonometry in the next unit, oh, it's going to be online, but maybe I can still share it with you. There's a really good YouTube video that shows you the link between music and math, and it like the graphs that we're going to be graphing out in the next unit shows like the different sound waves and how it's linked to what we're going to be studying. So, okay, I'm going to take that as a sign that we're done. Okay, what would be the first step if we're trying to evaluate this? Use the power rule to move the 6 and the 2. Okay, so 6 log base 3 of 3 minus 2 log base 3 of 3. And what do we know about these two? Yeah, they're just gone. So what's the answer? The answer is 4. Yes?
I think I did it wrong, but I did it differently. I ended up with log 7 by 9 over 9, which is log 81.
I'll have a look at yours after. Good? Are we good with this? I just want to very quickly mention this. It's such a subtle difference. Look at this. Log x squared. Do you see that this is like the stuff we've been doing? It's the same thing as 2 log x. 2 log x versus this. If we have log squared the x, any ideas? Like we haven't done that yet, but what do you think that that means? It's such a subtle difference. Pardon? The base of this is 10, and so is this one, but look at where the squared part is. What do you think is squared in this case? Yeah, thanks, Jolie. So here it's log x times x, and here it's the log part that's squared. So this would be like saying log x times log x. Does that make sense to everybody? I just wanted to point it out because it's so nitpicky, it's so detailed, but I want to draw your attention to it because you'll see this come up. And it's kind of like this. Like if you have x plus 4 squared, we're not allowed to do this, right? But people are often tempted to do that. So know the subtle difference between those. There's your work, and we'll do the other video or the other part of the lesson shortly.